Welcome to Esters. So glad you're in a different spot in class. It's like a whole new world. Functional group of an ester. Right, so esters, remember, they're formed by the carboxylic acid and the alcohol coming together. So I'm going to have this COO in the middle. And on this side I have a hydrocarbon, and on this side I have a hydrocarbon. Okay? So before, with my functional group, I represent my hydrocarbons with an R. Yes? And this, so therefore this is an R as well. But this isn't necessarily the same as this. And so this one's called R, and this one's called R prime, to indicate that this is the same but different. Okay, a similar thing, it's still a hydrocarbon, but it's not necessarily the exact same hydrocarbon. R and R prime. You'll use that a lot in calculus, if you take calculus. Okay, so the general formula of an ester is the same as that. Ditto. You don't need to write this down.
I haven't figured it out. I just didn't draw the arrow yet.
Did you do this while I was doing it with Taylor?
Oh yeah.
How's an ester made? Well, we've already just made it in a condensation polymerization. So we're going to take a carboxylic acid and an alcohol, and we're going to make an ester and water. So esters are super important because they are your perfume industry, your flavorings, artificial flavorings industry, like as in like peppermint for your making peppermint flavored candies or whatever. They are your flavoring as in like strawberry scented and strawberry tasting lippy. They are your aerosol, I love my car to smell like pine trees. Why do you have the air, like, why do you have the pine tree smelling car thing? Who wants their car to smell like a pine tree?
Just a nice fresh smell.
Okay.
Outdoorsy kind of person.
A big smell. Right, so anyway, banana flavored, antibiotics, all esters. Okay, so esters are super, super, super important, and that's why we covered them with Le Chetier when we talked about the equilibrium arrows, about making the ester, and that's why we focus on them here too. Okay, so to name the ester, we have to look at the alcohol and the carboxylic acid that it came from. Today we're going to name easy esters. Tomorrow or Monday we'll name difficult esters. Okay, so although a lot of this isn't easy or difficult. So if you find the O that's by itself, not the O in a double bond, and you go away from the double bond, that bit there came from the alcohol. And if you grab the double bond and you go away from the oxygen, that bit came from the carboxylic acid. And it's really important to be able to identify which side is which, even if this molecule was rotated. So if I had written this molecule like this, CH3O, C11O, CH2, CH3, again, I would take the O, go away, this one's the alcohol bit, take the double bond O, that bit's the carboxylic acid. So it's really important you identify what came from what side do I go, etc. Okay? That's the same molecule, just flipped. So it's going to be named the same. So I look at that and I think, what alcohol did that come from? Methanol. Everybody see that? Methanol? And I change, and the steps are written above here, so I'm just saying the steps but you can read them. You're going to change the name of the alcohol. Instead of methanol, I'm going to change it so that it's like the branch name, methyl. So the alcohol becomes the branch, methyl. Everybody see that? And then your carboxylic acid, which used to be propanoic acid, now becomes propanoate. So the oic acid bit
Junior class change
has been crossed out, and we have O8 at the end. So this is methyl propanoate. This came from methanol and propanoic acid. Okay? So this bit, find your O, go away from the carboxyl group, the carbonyl group. And that was your alcohol. So how many carbons in your alcohol section? 2, so it's called F, and then YL because it's changed to the branch name. So the bit after the oxygen is ethyl. And this bit here, 1, 2, 3, 4, bute, NO8.
They write them as separate words.
No, it must be the same word. It must be one word. One word. I have to do some thinking there though. I might need to look a few up. Because I must say in common speak, there's a space there. Like when you go and find, if you were to grab your bottle of Febreze at home and you were to look up what esters are in your Febreze bottle, there'll probably be a space there. But I'm trying to remember the IUPAC name. Is it one word or 2? Can't remember. I can't even see from all my typing that's a space or not, because I would have looked it up before I did that. Okay, propylmethanoate. Can you draw that for me? 30 seconds, and then I'll put this on the board, my answer. Yes.
If you write CH3 instead of H3C, is that still wrong?
No, it's not wrong.
Same thing. Oh, it's like that question. Oh, Mrs. Reese Brown.
Yes.
Oh, it's one of those.
Yeah. It's just because the H's are the other side. They're not in here. The H's aren't attached to the C.
So would you prefer if you put the H on the other side?
I prefer to put the H on the other side, yes.
So you
But
want to mark this wrong?
No, it's fine, too. But it's the same with Emily's question, why do they write it backwards? Why was that C-O-O-H written left to right? H-O-O-C, right? Same reason. Other questions? Do you see that they're both the same? Okay, so now I've got a whole sheet about organic esters. So let's do this. Let's do the first one together, and then you're going to end up with a couple branched esters. So you're going to have an opportunity to try naming those, but we'll really focus on those on Monday. So it says to write the whole reaction. So propanoic acid. How many carbons?
3.
1, 2, 3. Where do I put? And then do I go and then COOH? No. Just right away like that. Good. Butan 1-ol is the old-fashioned naming, by the way. It's bute and 1-ol like that. It's just old-fashioned. And so butan 1-ol is 1, 2, 3, 4 OH, right? Mrs. Reese Brown, can I write my OH on this side? Is that allowed? Of course.
Yeah.
Of course it is. Equilibrium arrows, because esterification always is. You should be so frantically writing you can never check your phone out of your pocket.
I'm not that straight. No, I'm joking.
Okay, and then what am I going to make? Put them together. So I'm going to take water, right? That makes water. So let's write the first bit here. H3, C, CH2, C double bond O. Now I'm going to go over here. Oh.
Just which? Okay, there's 2 each. bracket thing?
Which, oh yeah, sure. You mean CH2 bracket 3? Yep.
Okay.
What's its name?
Butyl propanoate.
Butyl? Is that butyl? Is this propanoic acid? So it's propanoate. Yep. So butyl, B-U-T-Y-L, propanoate. Yes?
For the alcohols, does the OH
No. And that's when you get your branches in the middle. Do you want to do one now? Kind of. You guys ready to do one of those? So, Miss Nielsen has just asked, does the OH have to be at the end for an ester? And indeed it doesn't. So let's put this OH, I'll just erase this now. Let's put the OH not in the end, but rather on carbon 2, shall we? So take out a hydrogen from there and put a hydrogen on there. This is now butan 2-ol. Okay? And so once again, I'm going to take my OH and my H, and I'm going to take those off. Okay? And so I'm going to get from here, I'm going to get blue. H3C, CH2, C double bond O, O, and then this C is attached to 1, 2 C's. 1, 2 C's. And this C is attached to CH3. And that C is 3H3. So this CH3 has, this CH3 has just become that CH3. That's okay, I just need to remember not to use it. Okay? Does that make sense? That CH3 has just become that CH3.
How do you name it?
How do you name it? Okay? So that part is my branch. And then all of a sudden I have a branch of a branch. So you know how I said you can never have a branch of a branch? Surprise! Here's a branch off of a branch. Merry Christmas. Or Happy Hanukkah, whatever. So, what's that called? It's called propyl, first of all, because I have 1, 2, 3.
So it's methyl.
Okay? And I have a methyl off of carbon, what do you think? 1, because this is going to be priority, so this is going to be carbon 1. So this is 1 methyl propyl. Make sense? I believe this is like somewhere, maybe I just can't see it, but like question 4 or 5 or something?
5?
Do you have a 2, butan 2-ol?
Yeah, but it's benzoic acid.
Okay. You got some space in the back anyway.
So the whole thing is called.
Oh no, just this bit.
Isn't that a C? Is that a CH under the CH3? Is it need to have God?
Here? Yeah, I need an H in there, yes. So, that is that.
And then what's the whole thing called?
So, and then I have this section which is 1, 2, 3, so that's prop and oic acid, so propanoate. And if I had a branch off of that, I would tuck that in here. So if I had a branch here, like this, then this would become a methyl in there.
Could that be off carbon?
You could put the 2 in, but it doesn't. You don't need to put, because it's such a short chain. It's the only spot for it. So, but if I had to, I'd put the number in there too. Yes.
Okay.
So 1 methyl propyl, methyl propanoate. So how do I know that that methyl belongs to that guy? Well, first of all, it's right before that name. Second of all, if I wanted to have two methyls off of this, I would have put it here and put dimethyl. It's not dimethyl, it's methyl and blah, 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 methyl. This is alphabetical, then this is alphabetical. So they're treated as very separate naming systems, and you can see that they're separate, and therefore you can then separate them.
Wait, what's that bottom one with the arrow? What's that?
That's saying if I had this, I would put a 2-methyl in here,
Oh, so that
but I
doesn't
don't.
exist.
So I don't. So tomorrow, I'm actually going to get you to make these with a piece of paper and rip off the water and stick them together. And you'll be able to see a bit more about how those become branches. Okay, yeah.
It's just something small. Do you look at propanoid or propanate?
Oh, thank you. Propanoate. Yeah, I've done that, right?
Yeah.
What have I done wrong?
I just didn't understand because don't you drop the oleic acid?
I dropped the oic acid
And
and add O8.
What the oak?
oh,
It's always there. All the esters that you've named, you should have ended in O8. Have you? Did you?
No.
No, okay, so just tuck your O in there. Okay, but let's go back to the simple ones. Let's do number 2 together. Together, or can you do it on your own?
let's try it.
Try it on your own, and I'll put the answer on the board in a minute.
2 and 3?
Sure, and 4 and 5. Go.
And 6? Okay.